This is a webcam, but it's not really a camera, it's my ESP32, and it's running Pong. So how does this even work? Well, to my computer, this ESP32 dev board is just a totally normal webcam. So this is one of my ESP32S3 dev boards. There's nothing special about it, it is just a run-of-the-mill dev board. A quick shout out to PCBWay as they fabricated these boards for me. They handled the PCBs and I did the assembly, and the boards came out really nicely. There's a link to PCBWay in the description if you want to check them out. Now the nice thing about the S3 and other Espressif ICs is that they have native support. This means that they can behave like USB devices. And they can even act as USB hosts, so you can connect USB devices to them, but we're using it in USB device mode. Now once it's been set up to say I'm a webcam, the computer doesn't care what it actually is. It just sees a webcam, and as long as the ESP32 sends a stream of frames over USB, it just works. So in this video we've got 3 demos. First, we have a fairly boring test card. Then we have an animated GIF, and finally we've got a real-time game. So let's start off simple. So this is possibly the most boring webcam in the world. We're using the Espressif USB UVC device component, which lets the ESP32 act as a standard USB webcam. We're sending the video as motion JPEG or MJPEG. Now MJPEG is literally just a stream of JPEG images sent one after another. There's nothing very clever about it. In this example, I've baked a single JPEG into the firmware, and every time our computer asks for a frame, we just send the same JPEG data over and over again. As far as the computer is concerned, it's getting a video stream, even though we're just sending the same image repeatedly. It doesn't really care, it just sees a stream. So, demo 2. A static image is fine, but webcams are meant to move. For this demo, I baked an animated GIF into the firmware. When the ESP32 boots up, I decode each frame into an RGB frame buffer. I'm using Larry Banks' fantastic animated GIF decoding code for this. We then encode that frame buffer into a JPEG image. We do all this processing up front, and then just stream the pre-encoded JPEG frames. The GIF file already contains timing for the frames, so all we need to do is keep track of the time and switch new frames in at the right moment. I've kept the resolution pretty sensible at 320 by 240 pixels. There's a really nice online tool called EasyGIF that you can use to resize and optimize GIFs to get them down to a sensible size. Typically, on most modules, you might have 2 MB of flash to play with, so you need to get them quite small. Doing all the heavy lifting up front, decoding the GIF and encoding the JPEGs, is pretty nice. We are trading memory for performance, which makes streaming fast and simple. But what if we want to generate content on the fly? Can we do it at a decent frame rate, say 30 frames per second? Looking at the logs from the encoding and decoding, we can see the JPEG encoding on average takes just under 23 milliseconds. Now, at 30 frames per second, you only have 33 milliseconds total budget, so the JPEG encoding is going to take a huge bite out of that time. This means whatever we're doing has to be simple and fast, which does make Pong a pretty good test. So here we have Pong running entirely on the ESP32 and being displayed on our screen. We run a very simple loop. We update the game state, render that into a frame buffer, then encode the frame buffer as a JPEG and send it over USB. I have baked some stats into the game display, and we are just about getting 30 frames per second. The eStat is the average JPEG encode time, and the DStat is the game update and drawing time. There are definitely ways to make this more efficient. It is a dual-core chip, so you could draw on one core while the other core handles JPEG encoding. There's plenty of optimizations you could do. Now, there's plenty of things you can do. I've just done a very simple game, but you could use this for dashboards, visualizing sensor data, or even testing video pipelines. So if you're doing simple dashboards, you probably don't need 30 frames per second. You could probably update it every 1 second, so the JPEG encoding wouldn't really matter that much. But there's many things you could do, so if you've got any ideas, put them in the comments and we'll try them out.